Hello, so in this lecture we continue with question 1 of tutorial sheet 3. We will be covering part D. So before we go on answering questions, there are just some logarithmic rules that I want us to understand, or that I want to state, which will in turn help us to solve our questions. So firstly, the first is that whenever we have log to the base a1, so this is always equal to 0. This is always equal to 0. So how we can prove this is that firstly, when we write the exponential form of this, we know that this will be a to the power 0 is equal to 1. We know that any number raised to the power 0 will always give us 1, so meaning that's correct. Another way in which we can demonstrate this, this is the same as log a raised to the power 0, right? Because a to the power 0 is equal to 1. Then using logarithmic rules, this can then drop to be 0 log a. Then we know that 0 multiplied by anything will give us 0. So that's how we can prove that. So always when we have that, it will give us that. And then also the second one is that whenever we have this is always equal to 1. So whenever you have a scenario where these are equal, please know that the answer is always equal to 1. Okay, another way in which we can prove this, when we write it in exponential form, it should make sense. So this is the same as a raised to the power 1 is equal to a. And that is true. Okay. And then for our third, we have whenever we have x raised to the power log of x y, this will always equal to y. This will always be equal to y. So in order for us to prove this one, we will use numbers that are familiar with us, or something that will be easy for us to calculate. So if say we had 5 raised to the power log 5 25, using this the third rule that we have stated, we can easily cancel this out and say our answer is equal to 25. But if we want to prove that, we can, let me just rewrite it. So we have 5 and then log 5 25. We know that this can then be written as log, or is the same as log 5 raised to the power 2, right? And then this is the same as 5 2 log 5 5. So the 2 drops. Then log 5 is 1. So this is the same as 5 squared, which is equal to 25. So the easier way is whenever this, the base there is the same as this, whenever this on the power there is equal to that, this can always cancel out and you remain with your answer. Yeah. So I think with those rules, with those 3 rules, we will be able to solve our questions. So without further ado, I think we can go to our first question. So remember, we have been told not to use a calculator. So we will try by all means to make sure that these logarithms that we have, we try in a certain way to match them to these that we have here, to these rules that we have here, so that we easily find the answers. So for the first question, for our first question, we have been told that log 4 64. So usually whenever you've been given such a question, you need to ask yourself, how can you make these the same? Because if they're the same, we know that we can easily simplify them. So one of the ways in which we can equate them, we can rewrite this as log 4 equal to, that would be log 4 raised to the power 4. That's another way in which 64 can be written. Okay, so that should be, it should be raised to the power, it should be raised to the power 3. Is it 3? Let me just confirm on my calculator. 4 times 4 times 4. Yeah, so raised to the power 3. And then the 3 will drop. The 3 will drop. So that will be log 4, 4. And then, as you can see, this log 4, 4 is the same as 1. This second row that we have there. So meaning this is the same as 3 multiplied by 1, which is simply equal to 3. And then I think on our rules, let me just add the fourth row so that we shouldn't be confused. So whenever we have, say, log AB raised to the power C, this is the same as C log AB. So the power can drop and come down there. Okay, so that's question 1. Then question 2, we have log 6 1. So this of course is equal to 0, right? From this rule that we have there. But usually examiners would want us to see if you really knew how you came about with the answer. So this we can then rewrite it as log 6, then 6 raised to the power 0. Then the power is going to drop, so we'll have 0 log 6, 6. So 0 multiplied by log 6, 6 is simply going to give us 0. So that's our answer. And then for question 3, if you can see, it's using this third rule. And I know most of you already looking at the question, you can already tell what the answer is just by looking at the question, right? So our question 3 says question 3 says 2 raised to the power log 2 7. So already here we know that our answer is equal to 7. Our answer is equal to 7. So how we can answer this? We can even state to say that for x log xy is equal to y, then this 2 log 2 7 will simply be equal to 7. The answer is simply equal to 7 because this is going to cancel out. So we'll just remain with 7. We'll simply remain with 7. So we proceed to the next question, question 4, which is log 9 27. So let's solve it on the next page. So for this one we have log 9 27. So remember, we need to try by all means to make sure that the bases are the same. So firstly, we know that we can rewrite this as log 9, then 3 raised to the power 3, right? And then we know that 3 So we know that the square root of 9, is equal to 3. So when we write 9 raised to the power half, we know that it is still the same thing as 3. So what we just want the bases to be the same. So meaning this, we can then say log 9 raised, so we write 9 there, raised to the power half, then with the 3 outside there. So this is the same as log 9. So this can multiply, that would be 9, 3 over 2. Then the powers can drop, so we'll have 3 over 2 log 9, 9. So since this gives us 1, so our answer is equal to 3 over 2, or if we write it as a mixed fraction, we can have 1 over 2 like that. So that's our answer for question 4. And then our question 5. This is our question 5, log 4 half. Our question 5, so let's just erase this. So for our question 5, we have log 4 half. Okay, so this is all about rewriting it in a way that will favor us to simplify it without using a calculator. So this is the same as 2 raised to the power negative 1, because remember 2 raised to the power negative 1 is the same as 1 over 2. Because it's the inverse, so we can write it as that. And then also, since we want the base to be 4, we know that the square root of 4 gives us 2, or 4 raised to the power half is equal to 2. Therefore, we can replace this 2 with 4 raised to the power half. So meaning we will have log 4, therefore raised to the power half like that. Then we know that we have that this negative 1 is the one that comes down there. So this then equals to log 4, then 4 raised to the power negative half like that. So the bases are the same. Then the power simply drops, so we have negative half, or negative 1 over 2 log 4, 4. This then becomes equal to negative half, because the log 4 is equal to 1. So we'll have that. Okay, and then that was our question 5. So we go on to question 6. We go on to the last question in this segment, which is question 6. So question 6 says, question 6 is log 1 over 3. So log 1 over 3, 27. So remember, we need to make sure that the bases are the same. We need to make sure that this is equal to that. So we can rewrite this as log 1 over 3, then 27, that is 3 raised to the power 3, right? And then we also know that 1 over 3, we know that the inverse of 1 over 3 is simply equal to 3, right? Yeah. So the inverse of 1 over 3 is equal to 3. So we can then replace this 3 with its inverse, so that it matches that down there. So this is log 1 over 3. Then we have 1 over 3 1 over 3. So since there's a negative there and we have a 3 there, the two can multiply, so we can have negative 3 like that. So simplifying this, we'll have negative 3 log 1 over 3. Okay, let me just erase this. And 1 over 3 like that. So this is equal to 1. So our answer will simply be negative 3. Okay, so we are done with part D for question 1. See you in the next part.